Hello there, this is Neil from Toolchefs and welcome to this video of the Stadium walkthrough. So in the first video we saw that how you can export the files that are necessary for configuring an agent type. Now what we want to do is we want to create some animation clips so that then we can use these animation clips for animating our agents. So the clips that I have, so I have some FBXs here that are actually used for, were actually done for this specific character. What I need to do is I'm going to go in the plugin manager first, and I'm going to load FBX, the FBX plugin, and I'm going to also load Atoms again. So basically the first thing that I want to do is I want to import the first clip, so it's going to be stand. And as you can see here, I'm importing the FBX on the same scene that I used for saving out the files, exporting the files for the agent type. And this is because in this scene here, my joints are already tagged, for instance, the feet and the pelvis. And if you have the pelvis and the feet joints tagged when you export your animation, Atoms will also save some special data on those joints. So for instance, it will store some pelvis height on this joint here on the pelvis, the feet height and also the foot down state on the foot tip, and also the height for the foot AK joints. So that's why we usually use the same scene that we used for the agent type. So okay, now what we're gonna do is we're gonna open the Atoms export animation exporter. I'm gonna go in the animation tab, select the root joint. So basically the animation will be exported for all the joints that are the children that are the children joints of the hips. So this hierarchy here. You can provide, of course, also extra joints if your detached joints are animated, so the prop joints, which is not our case, so we're not going to do that. And then you can either export FBXs, and Atoms clips, or USD files. FBX is, it's the most commonly used format type for this kind of stuff, but we find that FBXs can be quite slow, especially if you have a lot of joints and if you have a lot of clips. So we would recommend using USD or Atoms clip. Let's use Atoms clips. I'm going to call it stand. I'm going to then need to provide a value for the ground height. So usually what I do is like I select the foot tip and I click on this button, and this will basically set the ground height to the world Y value of the selected object in Maya. So it could be anything, like you could select this one. So anyway, that would be a bit too high. So let's just select the foot tip there. So by providing this value, we're saying to Atoms that the ground height is 2.7, right? But in this case, not totally correct. So how Atoms uses this value is this. So whenever we export the clip, the new Atoms clip or FBX or USD, we store the height of the feet and the pelvis compared to the ground, right? So if we say it's 2.7, in this case, we're saying actually that the ground is actually at the same level of this joint here, but it's not correct, because then when we're going to play this animation later in Atoms, we'll see the actual foot halfway in the ground, which is not what we want. So we could say maybe that the ground is lower, is maybe at 1.5, which would be probably approximately around here, and then we can provide a threshold, so it could be 1.6. So the threshold is useful because if we say 1.5 and we leave 0 here, we never, Atoms, when we'll export this clip, will never add like a foot state set to 1, so saying that the foot is down for this feet, because they will never be below the ground height. They will never be below the ground height. So what we want to do is like we want to provide a ground height which is makes sense for the actual height of the terrain of the ground, and then we can provide a threshold. So we can say if the foot tip is lower than 1.5 and the sum of 1.5 and 1.6, so it would be 3.1, then the foot is down. So this is basically our case. We want to make sure that when we export this clip, these feet are down. One thing that I should mention is that don't fuss too much about these values here, because you can always fix your clips later inside the Atoms UI. We have some ways for fixing them. So yeah, it's even if you don't provide the right values here, you can fix your clips later. You don't really need to go through this export process again. So I'm just gonna click export. This is gonna export my clip. Now what I can do is like I can import another clip. So I can say set to stand, and then here I'm gonna just say set to stand. I'm not going to change any of the values here because I know already that the mockup is working fine with these values for all the clips, for the same values with all the clips. So okay, so that's the sit to stand. Then I'm going to say sit here, and I'm going to import the sit like this. Okay. So sit is just sitting like this, nothing too complicated there. Great. And then what I can do is also I can import the stand wave, and we call this one stand wave export. Okay, so now basically we've exported all the clips that we need for these anyway this example. I'm gonna close this UI. I'm gonna create a new scene. Actually, I'm gonna open the other scene that I saved before where I configured the agent type. I'm not gonna save this scene because I want to keep it as it was before. So I need the character in T-pose. So I'm not gonna overwrite this scene. And in here, I'm gonna open the Atoms UI. I'm gonna actually clean this scene a little. So I'm gonna remove the man. I'm gonna remove these clips because I don't care about them. And then I'm going to start adding my clips. So anyway, when you click add, you see this panel here. If you don't know Python, just click on GUI mode, which basically will show up this UI, and then you can provide the paths and the values in this way. So I can say stand. I have just selected the clip, and you don't see anything in the viewport because we need to provide a compatible agent type. In the case of the Atoms clip, we don't store the hierarchy of the skeleton inside this file, so that's why you need the agent type. So basically that we can access that hierarchy from the skeleton file here. Okay, great. So we see here 316 is actually the say actually 313, and we want to provide leave some frames in between here. And then we say it's a loopable clip. The blend could be 3 frames. We don't really care because we know that the start and end pose are pretty much similar. So just 3 frames are going to be okay. We're going to provide the direction as a static value because you see the character is actually facing the z-axis. So it's just a matter of setting 001 here. And this is it. Basically, you can save this clip and you can use it later. One thing that we're going to do, although straight away on this clip, is to provide some transition frames that basically we'll see later with the state machine how they are useful. So basically, when you have this clip and you are transitioning between this clip with another clip to another clip, let's say to the wave, stand wave, for instance, that we had before, we exported before. Atoms usually what it does is if you don't provide any transition frame, it will go until the end of the clip, which is basically it's a long, it's a many frames. It's 300 frames, so you would actually wait a long time before actually the agents will go in the wave state. So what we are gonna do is we are gonna provide some values. So I know that for this specific clip, because that's how we set it up, we repeat the first frame every 50 frames like this. So we're gonna just say 0, 50, 100, 150, 200, 250, and 300. One thing to know is Atoms can also find those poses for you. If you want, you can use the auto here, this button and this tool for finding the reference the frames. So you provide a reference frame and then a tolerance angle, and then just click compute, and then basically this value will be populated for you. Okay, so that's it. I'm gonna click register, and now we have our transition frames. I'm gonna duplicate this one. This is gonna be called sit. I'm gonna remove the transition frames because we don't have any transition frame in this clip. Sorry, actually we have some, but let's just keep this clip a bit more linear. So we just have 0 and 150. 3 frames are fine. We keep the same direction and the compatible agent type, so that's fine. Register. I'm gonna duplicate this one. I'm gonna do the sit to stand, and I can do sit to stand. This one, yes, and great. So let's do 90, something like that. This is not loopable actually. So actually, let's do T3 static 001. So basically, yeah, here you see that I haven't checked this one. This value here because this clip is not loopable. It's actually, the start and end pose, they're not the same. Because this is actually a transition clip. It's a clip that we're going to use for going to the sit state to the stand. And this the state machine that we're gonna build in a second is not gonna be a completely and full state machine. Like we're gonna miss some clips for going maybe from stand to sit and so on. But it's basically it's still like a good starting point, you know, for we'll give you an idea about how you can build your own state machines. And finally, let me duplicate this one. Duplicate, say stand wave. Okay, 153. This is our 273. Actually, you can say set end frame like this. Okay, great. So that's all done. Loop blend is like that. It's loopable, static. Okay, great. Register. Okay, so all our clips are set up correctly now. So we can go here and we can create a clip reader module. So we can test our clips. So for instance, we can say, actually, let me create a couple more agents, say 1 per clip. And we say the first agent is gonna play the sit. Actually, I don't care particularly about the sit to stand, so I'm just gonna skip that for now. And then this one is gonna be stand wave. And let me change this one to 3. So we have just those. Let me change also the start frame to 0. So basically the start frame of the clip is actually 0. So because otherwise if you leave -1, we're gonna pick a random frame within the frame range of each clip. So I'm just gonna press 1 here, and these are our animations. So let's just check here that the loop is correct. Yeah, so it's pretty smooth, so we're happy with that. Otherwise, you can also test the loop here, test loop inside the Atoms UI if you want to try that. So anyway, our clips are okay. One thing to know is that Atoms will place your agents on the grid layout that we are providing. And the grid layout basically just creates a grid of points and then applies the agents on those positions. So in this case, you see that the grid is actually on the XZ plane. And in fact, because the root of our skeleton is the pelvis, so it's this joint here, we see that the agents, half of them are half part of the body is above the ground and the other half is below. So to fix that, we can say offset, apply pelvis side offset, and this will offset the agents using the distance between the pelvis and the average position of the feet. So that's why basically how you can get them above the ground. So basically the position that was created by the grid layout was probably here, and having that offset, we just move the agents above the ground like that. Now there's also another problem that you have probably noticed, is that the sit clip here is at another level, so it's not actually at the same level of the stand. Actually, this guy over here is floating a little. So to fix that, what we can do is we can go in the sit clip and then add a clip operator, and it's going to be the offset one, and we're going to click plus. We can click register, and then maybe we can provide here some sort of like value, say -20. We're gonna click register, and this will actually, if we're a wind, will offset our agent. You see, this is not accurate yet. And instead of just going through and typing values randomly, what I'm gonna do is just gonna like disable this offset operator for a second, display the world positions here. So here we see that the world position, the Y is 59 for the pelvis when it's at the first frame, while for the stand, if we zoom in, is at 102. So if we do 102.63 minus, so we said it was 59, it will be around 43, right? So we want to offset this one by 43 units, like that. Okay, so let me hide that. So now we should have them at the same level. If we look at them from the side, we see this like the feet of the character that is sitting, and the other feet are here. So anyway, it looks pretty accurate, so I'm pretty happy with that. Let me just change that and go back to perspective mode. Now another thing that you wouldn't care about it at this stage, but it's something that best to fix now before you go to the next stage, is it would be nice to have also the feet aligned when they are you know, all this, the feet aligned both from the seat position and also the stand position. Because if you think about it, like if you want these clips to be in a stadium, you will have probably the seats here. So this guy over here will actually be sitting in front of the seat, and then you would have to move it back, which is not something that probably we want. So what we're gonna do here is just we're gonna provide an offset. Again, we could do it in a more accurate way, but actually it could be -20 and non 20, something like this. So let's watch it from the back here. -30, -45. Sorry, I'm actually typing values here. You can see it, but I just put my -45 on the z-axis. Let's see if this value is accurate enough. Did I register it? Yes. Okay, yeah, it was too much actually. Yeah. So what I'm gonna do is I'm gonna set maybe -40. Yeah, okay. I think it's pretty good actually, but let me just be a bit more precise, because I want this to look as best as we can. Okay, cool. So that's okay. And now basically we can use these clips later. So I'm gonna save this scene so we don't lose our changes. And now we can work on the state machine. So here, as you can see, what we're doing, we're playing a clip reader. So, and this what can I do? It can actually just play one clip, but this is not what we want. We actually want to make sure that we can, you know, go maybe from the sit to stand state, and you know, from the stand to stand wave state and things like that. So I'm gonna remove the clip reader here. I'm gonna save again. I'm gonna go in the state machine. I'm gonna remove this one because I'm gonna create a new one. I'm gonna call it this one stadium state machine. Sorry, state machine. And then once you have created your state machine, you can right click in the viewport and start adding animation states. So the first one that we want to add is the sit state. Actually, let's add the stand like this. And then here we can add the sit like this. We can connect them together. So right click on one state and then connect with the other. And then we can create also the stand wave. Create a new state, stand wave like this. Okay, so right click there. Great, so that's there. So we have created 3 states, but at the moment they don't contain an animation. So what you have to do now is you can start dragging and dropping or adding clips here manually. But what I like to do is, like, I just like to open this panel. So I have sit selected. I'm going to add sit here. That's fine. I'm gonna stand, that's fine. And for the stand wave, great. If you have multiple clips, you would have probably to tweak a little, like for instance the merge type. So you might want to have them in random mode, because the default is merge, and it will actually merge all the clips together. But maybe, you know, like having random will actually just pick one clip, randomly one clip when you enter this state. So for instance, if you have 3 stand clips, then you can add them all to the stand state, and then you can select them all and click set the state, the merge type to random. Everything else here, it looks okay. I mean, we don't really care about this stuff that much. You have to care mostly about the ID. So the ID has to be unique. Atoms creates a unique ID whenever you create a new state by default. Just in case you have to you know, like you start editing the IDs, you have to make sure that the ID is unique. So another thing that we have done before, as you remember, we have created the sit to stand clip to have like a better animation. So if you can click on the connection, then you click again on this button, we have added now the sit to stand animation clip on this transition, and as you see here, we have now this circle. That means that we have a transition clip. We're gonna call it this one sit to stand. Okay, here we have some blend frames, so we're gonna say we're gonna blend 3 frames when we enter into this animation, 3 frames when we get out of this transition, which is fine with me. And now the state machine is ready. So you can go in this agent type, and you can just provide the state machine for that agent type, which is this one basically. So once again, just to repeat what a state machine is, it's just basically you build a graph that then is going to be used by Atoms for changing animation during the simulation. So to apply this state machine on this agent group, what we're gonna do is we're gonna attach a state machine module. As you can see now, because the state here is 0, this is basically picking the state with ID 0, which is the stand. And the stand, of course, is just playing this animation here, so it's the stand one. What we could do, for instance, we could open the override dialog and just say, oh, I want this guy over here to be in sit state. And now it's gonna be sitting. Now if I press play, they're just gonna play this animation, Some guys are still standing, the other guy is gonna be sitting until we do something else. We make them do something else. So for instance, for this guy that we just made it sit, we can go, for instance, to frame, so let's say, well, actually, less frames, let's say 20. We can set values already. So we can set a keyframe. We go next frame, you can say 0. So what this will do basically will tell Atoms that this agent will has to go from state 1, which was the sit, to state 0, which is the stand. So we should see this agent actually standing. And you saw that basically that didn't happen straight away, because the problem with that is that as I was saying before, actually Atoms tries to get until the end of the clip. So this sit clip has no transition frame, so we could provide some, although you have to be careful that basically the transition frames that you provide are gonna be pretty similar. So maybe you can even try to use that the auto button. Let's see. Yeah, okay, found some, but they're quite far away in the loop, so it won't make much difference anyway. Otherwise, you can just type some frames that they look similar to you. The animation is not really that different, so we could try like doing 0, 50, 100, 150, and so on. So you would have to experiment a little here. This way, yeah, 150, something like that. So for instance, now we press rewind and we're gonna press play. Now you see it's actually standing way before, because we have provided some transition frames. So that's how transition frames work. So it's pretty important that you provide them if you have very long clips, okay? So, okay, if we press play, now this transition looks okay because we have that transition clip. If we want also, we can say to these guys over here, do a wave. So let's say we can go, anyway, here as well, we select these two, say key, next frame, the other, the wave state is, send wave is 2, so we say 2, and if we press play, that's great. So you see that basically that animation is playing. You see that they're a bit out of sync because again, they are starting at a different frame, the animation, and they reach, basically Atoms tells them to switch animation at a specific frame. So it would be one of these. So that's why one of them is starting before the other. If you care about having them playing straight away, you can do this trick. So you can do attach another metadata module. Sorry, add metadata module. Here you can do add this metadata that is called force clip transition, which is a boolean, and you say you activate it and you set it to true. So what this will do, we basically will tell Atoms to ignore the transition frames, but actually just to play the other animation straight away. This is all for this video. Thanks for watching.